Question 8 says that if the non-parallel sides of a trapezium are equal, prove that it is cyclic. So a trapezium is a quadrilateral in which one pair of sides are parallel. The question says that if the non-parallel sides are equal, then prove that the trapezium must be cyclic. So here's a figure that I've drawn for this problem. ABCD is a trapezium in which AD is parallel to BC, this side is parallel to this side, and the non-parallel sides AB and DC, they are equal. And using this, we have to prove that ABCD must be cyclic. Now, to prove that a quadrilateral is cyclic, we can prove that the opposite angle pairs are supplementary. For example, we can prove that the angle at A and the angle at C, these are supplementary. If we are able to prove this, then it follows that ABCD is a cyclic quadrilateral. Now, because AD is parallel to BC, the angle at A and the angle at B, we already know that these two angles would be supplementary. So we know that angle A plus angle B must be equal to 180 degrees because these angles form a pair of co-interior angles for the two parallels AD and BC and the transversal AB. So we already know this. We know that angle A plus angle B is 180 degree. What we want to prove is that angle A plus angle C, the opposite angle to A, this sum is 180. This is what we want to prove. So if we are able to prove that angle B and angle C are equal, it will follow that angle A plus angle C is also 180 because we already know that angle A plus angle B is 180. So the objective of the proof will be to show that angle B is equal to angle C. So this is what we want to show, and this is the reasoning that we're going to use in this problem. So here's how we can show that angle B is equal to angle C. Take these vertices A and D and drop perpendiculars to BC. So from A, drop a perpendicular to BC, and from D also drop a perpendicular to BC. So these are the two perpendiculars. Let's call the feet of these perpendiculars M and N. Now I want you to think about the triangles ABM and DCN. So I'm going to highlight these for you. ABM, this triangle, and DCN, this triangle. These two triangles look congruent. Let's prove that these are congruent, and from there it will follow that angle B and angle C are equal. So in triangle ABM and triangle DCN, which are the corresponding parts that are equal? So we know that AB and DC are equal. This is given to us. The non-parallel sides are equal. So AB is equal to DC. This is given. Also, AM, this perpendicular, must be equal to DN, this perpendicular, because these two perpendiculars are between the same parallels and the perpendicular distance between two parallels always stays the same. So we can say that AM is equal to DN because both of these are perpendicular distances between AD and BC. Okay, and we also have angle AMB and angle DNC. Both of them are equal to 90 degrees because AM and DN are perpendiculars. So angle AMB is equal to angle DNC. Both of these are equal to 90 degrees. So what we have here is two right angle triangles in which the hypotenuse and one side pair are equal, and this means that we can apply the RHS congruence criterion, and we can say that triangle ABM is congruent to triangle DCN by the RHS congruence criterion. And from this it follows that angle B is equal to angle C by CPCT, by corresponding parts of congruent triangles. Now, as we discussed earlier, if angle B is equal to angle C, it follows that angle A plus angle C is equal to 180 degrees because we know that angle A plus angle B is 180 degrees because these are co-interior angles, and angle B is equal to angle C. We have proven this. So it follows that angle A plus angle C is equal to 180 degrees, and this means that ABCD is a cyclic quadrilateral. So this is the proof for question 8. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.